Okay, this vid is going to address some comments from my last vid. Um, People were asking, I'm using a mechanical switch here to put zero point 0.4 volts in this case. Let's go to 0.5 across this coil, and then when I release it, the inductive kickback comes out of the coil through this diode and pulses one of these coils. It's a regular coil with a capacitor across it as suggested last night, and this is a bifilar coil, and TK had suggested to put a value of cap across this coil, and what I did was I went with a value that came close to resonance as this coil does with its own capacitance. So this one's about for some reason right now it was like 12.88 a little bit ago, and it seems to be reading on the scope in the 13 kilohertz, and this is at low mid 12 kilohertz, so they're close enough, just for these tests. But there's going to be some weird things. Now, when I'm at 0.5 volts, come on, when I'm at 0.5 volts and I flick this switch and I close it, charge this up, and then I release it with my thumbnail, I'm letting that spring jump it out, and it's shows, let's see, flick it, a very consistent, there's nothing really crazy going on at the beginning of it. I mean, you'd think that there might be some sparking, but there's not. And it's most likely because it's low voltage. I mean, our output, or peak to peak, is like less than a volt. So that's with the bifilar coil. Now we're going to switch over to this coil, which in my last vid, without the capacitor, would impede the kickback from here, and you can see the spike on the screen. But now it's very similar to acting like this coil. So here we go, we're going to flick. Okay, this is the single wire coil. Let's see what the frequency is there. But take a look at that. Now I'm going to flip the switch. We're on the bifilar coil now. Okay. Very similar. I mean, this has a little bit more voltage output than the regular coil, okay? Let me see, I pulled off a clip here that's holding up my wires. Now, what we're going to do is we're going to jump up to, let's say 3 volts. Okay. Flip this over to the regular coil with the capacitor. Okay. This is the regular coil with the capacitor. 3.6 volts peak to peak, and however long this waveform is. Now we switch over to the bifilar coil. Much different looking waveform, more of a triangle than a quickly decreasing trumpet. This one's at 5.1 volts peak to peak. Alright, we're going to switch back to this coil and go to 10 volts. Alright, let's see. We're getting from the stereos, getting some popping noise. Let's see. Okay. So we're on the regular coil. Got that one pop out of the stereo. We're at 10 volts. So now we need to change our scale. Alright. Okay, this is the regular coil with the capacitor. 10.2 volts peak to peak. And the frequency is changing. going lower as we increase the voltage. This is the only thing I'm changing, is this and the switch and my thumbnail. Alright, now we're going to flip over to the bifilar coil and start flicking. It's a much healthier looking waveform. What are we at? It says 16.9. We're actually off the scale. We need to jump up. 17.2 peak to peak. Still 13/8 remaining. And now we'll flip back to this since we changed the scale and see the difference. This regular coil with the capacitor is dying out pretty darn quickly. This capacitor is a 500 volt capacitor. We haven't even approached that, so it's not the capacitor failing. So let's go up to 20 volts. Alright, flip this to the regular coil. Now we hear our stereo popping. Now we're going to start seeing noise at the beginning of our switch. If I don't get it right, there we go. Now if I flick, 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 flick. Now if I just push, if I'm just this, right, we get a lot of that. That's the rubbing. So if I flick, we get that half decent at this high voltage. We get some consistency here. See what our frequency is, 9.72. Okay, now we go to the bifilar coil. Much healthier waveform. I'm seeing 33 peak to peak in one shot. Flip it back. And this is our regular coil. Alright, so far, just changing the voltage, there is a difference in how these are going to output. You know, I go down to 0.5 volts and it's pretty much dead nuts. They look identical in a way other than a frequency difference. And this one being just maybe a volt or two, whatever it was, higher than this one. And then as we increase the input voltage, the difference between this one and this one becomes more evident. Whatever that means, we'll figure it out. So far, you know, we're looking at things in a different way, I believe. Let's check it out. Alright, thank you. Bye-bye.